Okay. So I guess my screen is visible.
Yes, yes.
Okay. All right. Just trying to find. Okay, cool. So good day, everyone, and thank you. So I would like to thank the organizers again for inviting me to this forum and giving me the opportunity to talk about my work. So I'm a human-computer interaction researcher based in India. So let me take you back a little bit. So I graduated from a city called Nanded as a computer science engineer, and then I moved about 600 kilometers west to Mumbai, where I am based for more than a decade now. In this presentation, I will talk about some of my work with three research groups based at Indian Institute of Technology, Bombay. So I had the opportunity to work with a research group called Developmental Informatics Lab at IIT Bombay, led by Professor Krithi Ramamritham. There were several lab partners that the lab was working with, including IPID-Asia and Vigyan Ashram. So the motto of the lab was ICT for empowering emerging regions. So just to give context, this was way back in 2000. So I started working with them in 2006, but the lab was established much before, I think 2003 or a little earlier. So some of that information might feel a little dated because of that. Okay. So essentially, the motto was how do we use existing ICT tools to bridge the digital divide? The team was a mix of software engineers, interns, master students, filmmakers, translators, agri-domain experts, graphic designers, product designers, a whole medley of people at different points during the project. So this photo that you see here have some of the team members, not all of them, and that's me. Uh, Younger days and so on. So it was very inspiring to work with the group as a fresh computer science graduate. Uh, so this is a quote by a famous information security personality and my mentor, whose photo is here, Anil Bahman. He used to say something on similar lines that as technologists we like to think that it is the solution to all problems, but we have to remember that that is not so. It is just a tool. And I think so. I remembered that echoed yesterday in several presentations, and I thought I should definitely add this slide here. Okay, so one of the main projects at Development Informatics Lab was called Aqua, which was started in 2003. It stood for almost all questions answered. It started as all questions answered, but then they said it is too optimistic to say all questions answered, so let us call it almost all questions answered. Uh, so to give a context here, India is a largely agrarian economy. As of 2018, even now, about 59% of the workforce is engaged in agriculture and related sectors. Indian farmers, especially the small farmers, use traditional farming methods. So the crop yields are much lower as compared to other developed and developing countries. So in India, there are agri extension centers that are called Krishi Vigyan Kendras or KVKs. They are usually associated with the agricultural university. The idea behind establishing them was that they have testing facility. Universities usually have testing facilities and expertise to support farmers with localized information about weather, soil, farming techniques, and so on. So the emphasis is here is on localized. Though the weather department puts out weather data, its granularity is still not fine enough to inform farming decisions effectively. So from what I understood, farming decisions are influenced by many factors like weather, soil conditions, and they could vary within the same neighborhood a lot. So one of the important roles of KVKs is precisely this, to provide localized advisory. So India has about, I think, 700, more than 700 KVKs across the country. Um, so the idea here was that ICTs could actually be used to create a platform to facilitate communication between Krishi Vigyan Kendras, which had the expertise, and farmers to improve their practices. So remember that this was when mobile phones, smartphones were not very common, and even mobile internet was available only in few places, and it was very expensive. In fact, even in remote areas, like I think Professor Belloor mentioned, Dr. Belloor mentioned yesterday, last mile connectivity was always an issue. So in this picture, you will see there was a lot of effort taken to reach out to farmers, understand what their issues are, and so on, before the actual system was designed. And the last photo that you see in the right hand corner bottom is actually a setup for wireless local loop to actually provide the last mile connectivity in areas which are really far, which do not have fixed lines and so on. So this is sort of the interface for Aqua. It was a platform where essentially farmers could ask questions and get their questions answered. Uh, but the thought that went behind it was maintaining quality of service in low or no bandwidth uh, environments, plus recognizing that the target users needed the content to be pushed. We cannot expect them to be pulling content, actively searching for content, and so on. And obviously, multilinguality was an important factor as well. So in 2006, smartphones had started to become a bit more affordable, more commonly available, even in smaller towns and villages. And so we started to explore what could we do to translate some of the content and ideas to mobile phone. So for example, these are some examples we had of supporting how to search existing content and internet for related information. So if you see there's something called keyword browser here. So if you want to search the forum, you don't really type in a search term, but you sort of go through a bunch of keywords to actually reach the content that you're looking for. So these were some these are some small nuances that were thought of and added to the system to make it more accessible to the target audience. Okay. So these are sort of summarizing the technology that went behind it. So because the professor who was leading the project was a person from database and information retrieval areas, so they were looking at how can we provide quality of service in low bandwidth areas, do caching, prefetching. So none of these are groundbreaking or cutting edge technologies, but these were put together to provide an experience or provide access to people who otherwise wouldn't have access to it. That was the idea. uh, yeah. So these are some of the other projects that went on in the lab. So there's tangible interface that you see on the top. What this person is doing is actually is using a browser, but instead of using mouse, he's using this tangible interface with buttons. Then there was some work done on keyboards for Indian languages. There was some work done on iconic interfaces for people with low literacy and so on. I'm going to skip this. But what also came across is from the field, and which led to collaboration with other departments, is the needs that were identified from the field. So what people found is, apart from other information that that farmers need, what they also want need to know occasionally is the kind of water that they have access to, with what is the pH and what are the proportion of different minerals and so on. So usually they have to rely on labs which are far away to get this done. So then there was a project done to develop low cost sensor water quality sensors. Great. So moving on to the next thing that I worked on. So this work was undertaken with the interaction design for Indian Needs Group. One of the first things that I worked on there was Indian language keyboard. So the screenshots that you see here are screenshots of a keyboard called Swarachakra. So it's a it's a it's a keyboard available in 12 languages on Android Play Store, and it has last I checked this morning, it has about 7 lakh active users. It has had I think about 40 lakh downloads so far across the 12 languages. uh, so again, to give a context, what is so fascinating about text input in Indian languages? So there are several challenges in text input in Indian languages. So these are the four primary ones. Sheer number of characters. We have more than 60 characters set, this is true of many other Asian languages that are there. That the sheer number of characters set is very large. Also the sequence. For example, if I'm trying to type the syllable ka or the syllable ki, I would use the same consonant ka here, but I would use two different vowels, a and e, to get ka and ki. So in both instances, I would type the consonant first, followed by the vowel. But once it is typed, visually the two of them look different, and this causes confusion when you are typing. Then and the third challenge is typing conjuncts. So if you're trying to type a syllable kl, so here for Devanagari you would have to combine k and l to get kl. So you would use this red symbol which is called halanta to do that. And this is not something that is known by everybody, and hence typing conjuncts is very easy. So what we tried to do was simplify some of these issues when we built Swarachakra to make typing in languages a bit simpler. So let me see if the video works. Here's a video of how Swarachakra works. So effectively you tap on a key and you get the combination of that consonant with vowels. And if you're trying to do a conjunct, then you get a preview. So this was also the time when Android smartphones had started becoming very, very popular in around 2013 or so. So we put out our Android keyboard, and in 2016 we got the opportunity to actually compare, to do a study to compare different Indian language keyboards. So what we did is we evaluated 4 Marathi keyboards that were available out there, and we had some interesting results that came out. So just to give a very quick idea about what these 4 keyboards represent. So the first two keyboards are essentially similar. They are based on the frequency, but um, but the first one has prediction available, whereas the second one doesn't. Similarly, the third and fourth keyboard are both based on the sequence of the language, but the third one has prediction, the fourth one doesn't. So the last one that you see is Swarachakra. So we ran an evaluation and we found that we would have expected that if you had prediction in a keyboard, then you would the performance, the typing speed would be much higher. But if you look at the results here, the first and the third column represent keyboards which do not have prediction, and the second and the fourth column represent keyboards that had prediction in them. And you can see that the keyboards that actually had prediction did worse than the keyboard that didn't. So that was an interesting realization that though prediction might help for English, it is not as easy a problem for Indian languages. So the next thing that we got a chance to work on was accessibility. How do we make keyboards and things like that accessible for visually impaired users? So one of the things that we got a chance to try out was create a accessible Indian language keyboard. So let me just show how that works. So I don't know if anybody has. I remember hearing So I remember reading in the schedule that there's somebody who's worked in accessibility, but I don't recall who it was. Uh, I don't know if they're joined today. Has any? Ah, okay, no. All right. So just to give you an idea, when you're typing on a smartphone in accessibility mode, there are two things to it. One is you would explore with your finger to find. So explore to touch or touch and explore, and then you would do a second gesture, either a tap or a second finger gesture to actually do a selection. So it's quite laborious. So that's what you will see.
Da, ka, kushi, ku, ku,
So there's the
ga,
explore by
cha,
touch.
da, da, ba, fa, ba, ba, da, ba, la, space, ku, cha, da, ba, ya, ra, la, latkale.
So as you can see, it's quite laborious to type. Like each typing each letter is multiple steps, but that's how it is at the moment. So we thought, what could we do to improve the performance of typing in any language keyboards? Uh, sorry. Yeah. So we got a chance. So we are interaction designers. So what we do is we make something and then we evaluate it to see how it performs. So we got a chance to evaluate it. So we compared Swarachakra accessible with a Google Indic Hindi keyboard, and there were some interesting results. So we didn't really find much difference in terms of performance. So Swarachakra was better than Google Indie Keyboard in terms of speed, but not significantly. What we found though was, which was clearly to be expected, is that the benchmark speeds that people typed at were much lower for inaccessible mode, which was to be expected. Yeah, and yeah, so this paper that we wrote to Interact won Interaction Design for International Development Award. So taking going from there, this was now in 2018 or so. So speech recognition technologies for Indian languages had come far; their accuracies had improved. So we thought, if we want, let us see if speech typing or voice typing can help us improve performance on Indian language keyboards. So we ran a study where we compared keyboard typing, like you saw before, and keyboard plus speech typing, like your voice typing, a combination of that. And we ran evaluation with visually impaired school children, and the results surprised us as well. So obviously the keyboard only was going to be slower than keyboard plus speech, because in speech you can speak much faster than you can type. But the speeds that the visually impaired kids actually reached were much higher than the speeds that were reached by our users in a prior study that we did with university students. So that was surprising and a pleasant surprise at that. And so just to give you an idea of what are the errors that what are the hindrances in voice typing. So if you look at the kinds of errors that the voice recognition engine makes. For example, if you want to type output, you would say output, and the recognition engine could actually write it either the output without a space or a space in between. But if you are going to evaluate the word strictly, then the second is obviously incorrect, and then it would count as an error. Or if you are trying to type a word like rukhsat, the recognition engine might not have that in its vocabulary, and it might write it the first way around, which is incorrect. I mean, you can tell what the user's intention was, but it is still grammatically, it's not the correct spelling. So these are the kinds of errors that crept in just because of the voice recognition system. And these are kinds of errors that visually impaired users would have difficulty identifying, because they wouldn't read it. So even if they listen to what they had typed, the output with a space and without are going to sound more or less similar. So these are the errors that they wouldn't be able to identify. So those were interesting thoughts that we had about how, what do you count as error, and what you shouldn't. So to give you an idea about what these error rates look like, so these are the error rates. On the left hand side are the errors that cited university students made, and the error on the right hand side the graph shows errors that visually impaired school children made. And so you realize that the errors are not too high graphs. So I'm not going to go into the details of what is CER and so on, but too many details. But because I want to also speak about this last project that is there without exceeding my time by too much. So this is the one other project I worked on with the ID group led by Professor Joshi at IIT Bombay. So this was a study we did way back in 2016, where we were trying to understand the uh, so we are trying to actually understand two things. This was done in collaboration with Baby Center and Dasra. I'll probably skip this video and yeah. Uh, so the partners that we were working in, they had already deployed a program called mMitra, which had an IVR service. It was an automated voice call service that would send information over voice calls several times a week to women who are enrolled in the program. So this information would be related to uh, uh, okay, so the program was intended for women who are either currently expecting or who had delivered in the last 1 year, and the information was related to what should they expect, or the food that they could be having, or the common myths or common misconceptions that are there, and things like that. But the USP of this service was that the information was given in a timely manner. So if depending on where they were in the stage of their pregnancy, or how old how young the infant was, the information was very very relevant to that particular stage of their journey, and this made it very relevant. Right. So what we did as a part of this project was there were two phases to it. In first phase, we just tried to understand. Let me just go back a little bit. I also wanted to mention the motivations. We had two motivations as a part. It was a very short project, so we wanted to understand how do these women use mobile phones to access information related to health, nutrition, and so on. And what are the opportunities, because mMitra is IVR service, so what are the opportunities that are there if a smartphone based app or a system was developed to add on to the existing IVR service. So that was the goal going in. So in the first phase, we just tried to understand what people were up to. So this is sort of the breakup of the users, demographic of the users that we interacted with. So we had women from the ages of 18 to about 38. They had varied years of education, but we deliberately did not recruit people who are graduates. We tried to talk to people who had no education to maybe 10 years or so of education. And we obviously spoke to women in different stages of their journey as well. And of course, some of them were people who were enrolled into the program, and some of them were not. This also is an interesting thing that we found, that there's a lot. I think this echoes somebody's. I think there was a presentation yesterday that mentioned that a lot of phones are shared phones, so they are not owned by the women themselves, but they are shared within the family. So we found that to be true then. And there was a very small percentage of women who actually had smartphones. Yeah. So what we found, so we got their feedback on the IVR service that they currently had, and as I said, they actually were happy to receive the messages. The advantage of a voice call is it does not persist, so they could actually consume the content on their own time and privately if they wanted. Uh, if it was an app or a book of some kind, then there is a chance that somebody else could look at it, which a lot of people are not comfortable with. And yeah, so these are some of the interesting things that came out. The other thing we realized is because IVR is a very purely audio mode of interaction, audio mode, yeah, of getting content. So certain content is best explained if there are visuals to go along with it. Visuals also made it, people could browse through things, whereas in audio you have to listen to the whole entire thing. Also, we found that for certain things where actions or demos are being explained, the audio is not effective and actual visuals will make more impact. So for example, if you want to tell somebody that sleep on your side with a pillow under your leg or feet, then a simple visual like this will actually convey the information more effectively than just telling people about it. Similarly, some things are really not easy to describe. So visuals help explain things that are normally not visible. And yeah, on the downside, you cannot you cannot rely on visuals alone entirely, because they could be misinterpreted. So it has to go with some explanation, and the visual has to be localized for sure. So what we also found was that so the IVR service had a lot of content which was either in Hindi or Marathi, the two languages in which they piloted, and we realized that even within the same language there is a lot of difference in the terminologies that are prevalent in different areas. So, for example, sonography is a word which is understood in a couple of cities, but in some cities, ultrasound is more, is something that people understand. So, although Bhopal, the two cities, Bhopal and Hindi and Delhi, are both Hindi-speaking cities, but they are separated by geography, and their language, their Hindi uh, Hindi dialect, it's not dialect, but the usage is quite different. So we realize that super localization is the key to terminology as well as to visuals, and to then further sort of ground our findings in a broader geographical area, and to also investigate what are the technology abilities of the target user group. We did a second phase where we ran a questionnaire with about 102 users across multiple cities. And so this sort of summarizes the demographic of the people we spoke to. So a little more than 50% had their own phones. Rest of them actually shared their phones with their family. A very small percentage of them actually had smartphones, so about 25%. So this was, of course, about 3-4 years ago. So things might have changed quite a bit since then. Also, less than 50% of those actually use their phone calls for anything beyond making a call. So a small percentage, about 48%, they used it for taking photos or maybe watching a video or something like that, but not too many. Yeah, so we had some interesting findings related to the terminology. So what we did is we picked 11 common terms that are used in the mMitra content in two languages, and we did a study. We sort of did a exercise where we told the users the standalone term, then we added a meaningful sentence with that term in it. Then we added another longer sentence with even more context. And then we added a visual to go with the term, if applicable. And we found that while the term on itself was not as easily understood, just giving a meaningful sentence or a context to that word really helped people understand what the word was, even if they didn't know the word. And visuals for sure help for certain terms, but not all of them. I'm going to skip through this one. Yeah, so this is in conclusion. I think I've covered most of these. Yeah, so of course, what goes is super localization is the key takeaway, and beware of adding complexity. So most of these users don't use the current features that many of us are used to. So we should keep the app as simple as possible. So these were some of our takeaways from this project. And just one last interesting thing that I have been working on is with the Let's group. It stands for Learn Through Stories. So I don't want to go into too many details. The website is here. You can access. You can look at different things that they are up to now. But essentially, what the project aimed at doing is creating content with children. So if you see the image on the left side, these are a bunch of books that were co-created with school children, which were then brought back to the lab and then cleaned up and then printed into books and bound and so on. And then in the second picture, you see that some of these books have gone back to the community, and they are using a app that gives voiceover to the books. So as the children flip through the book, they can hear the voiceover of the same text that there is. So idea is to expose children in remote areas to the sounds of English language that usually they wouldn't have access to in their environments. Uh, yeah, so that is about it. Thank you so much. I'm happy to take any questions.
Thank you, Manjiri, for your presentation. Very great work there. So I have a few questions for you. I think one of them is from Dr. Esmeralda Manisa. So she asks, have you investigated how this technology are used by the illiterate members of the society? I think it will be very useful.
Yeah, that's true. Was this specific to any project, or was this a question in general?
It is a question, yeah.
Yeah, it's in general, because you're talking about, for example, the speech to writing, etc. I'm just like wondering whether that can be designed probably in the future for the illiterate members of the society. I think that will be also allowing them to actually, because many of communications now is happening through text messages, just allowing them to participate in that kind of communication, some things like that.
Yeah, so I just wanted to add two comments to that. So actually, voice messaging makes a lot of sense for people who are low literate because they can read, but they are not very comfortable with typing. So what we saw in several of our studies is, especially the one that I mentioned at the end, a lot of people searched YouTube for recipes and songs and so on. So they used Google Voice typing to input the terms. So they never used keyboards. So they would always type using voice, and then they would sort of browse through the results. So they are making use of that. So we have seen people do that. With illiterate users, what could happen though is, because voice recognition does make mistakes more often than not. So this, if you cannot read, then that is a tricky thing. Though you could always hear it back, and that helps. But yeah, but it has potential. So it for sure has potential for. So we are working on something, but since it's work in progress, so I couldn't add any slides about it. But we are working on an app. We are looking at mobile banking for people who are illiterate and low literate, and so we have not looked at how voice recognition could play a role, but we are definitely looking at audio prompts, because we know that icons are not really, I mean, they need, icons are misinterpreted, and it needs to be localized and so on, so you cannot really generalize icon based interfaces. So we are looking at voice prompts and all of that. Yeah, it's a good point.
Thank you.
There's another question here. So from Dr. Nila, how did you classify the users' respondents, measure the result? Is there any specific time you spent to observe the responses of this experiment?
uh, so I'm assuming this is the text entry experiment that Neela was referring to, the keyboard experiment that I spoke about. Is that right?
Yeah, exactly, Dr. Manjiri.
Yeah, so thanks for asking. We usually don't get too many questions about text entry, so we are always happy to speak about that. So what we usually do when we are, sorry? Yeah, okay. So what we usually do when we run text entry or keyboard evaluation experiments is, it's a very controlled thing, because we are looking at speeds and errors. So we usually have an app of our own, and so what we have usually done is, we use something called transcription tasks. So we show the users a particular phrase and we ask them to copy it. And what we do is, because they do the typing within our own app, so the moment they start typing, we sort of time them till the last character that they type, including any corrections that they do, and then we use that to calculate the time that they took. So the characters that they typed and the time that they took, and we sort of report this as characters per minute. So how many characters did they type in a minute? And that's the number that we use to compare across users. And of course, when we talk about speed in text input, usually you also have to report, how many errors people made. So people could be typing really fast, but they could be like typing all crap. So you have to also report how accurately did people type. So then that brought us back to when we briefed the users, we told them that type as fast as you can, but also type as accurately as you can. And then of course people still made some mistakes that they couldn't identify. Yeah. So we could actually classify our errors in two ways. So if you remember the graph that there was, maybe let me see if I go back while I speak. So there's something called corrected error rate and there's something called uncorrected error rate that we usually report. So when we say corrected error rate, it means the user wrote something, they realized it was incorrect, and then they corrected it. So that's the corrected error rate, like how much time did you spend correcting. And then uncorrected error rate is you made an error and you did not realize it. So that is like the error that is still remaining in the text. So we usually classify that to also tease out where the problem is. So for example, if you see in this graph, if there is too much corrected error, that is not good, because then the user is wasting time in correcting for whatever reason they are correcting. So here, for example, if you see the left hand side graph, the corrected error rate is 21.55. That indicates people spent a lot of time. 21% is a very high error rate. So it's people spent a lot of time actually correcting, which means their speeds went down because they spent that time. I mean, they spent that much time typing that much text and so on. So yeah. And of course, we also do, while we are doing the studies, we observe qualitatively, what happens, are people accidentally hitting this key and so on. So those are always there. Oh, one last one.
Oh, okay. Continue on.
So usually when we do experiments, we usually, in Indian languages, we do a longitudinal study. So these represent about 300 phrases that people typed over about 15 days. Because remember, these are all novice users, so they have not typed on a smartphone before. So hence, when we do a study, we do a long 10-15 day study to actually understand, the expert behavior. So, yeah, sorry.
All right. So there are a few more questions here from Leila's team. How much of the research has been done among women who are involved in agriculture?
It's a very good question. So actually, though I spoke, so this is about aqua, I believe. So I worked for a very short while in the towards the end of the project, and I worked on, I was a computer science graduate, so I worked on how to use Google's custom search API and things like that. But I remember meeting one lady. So I didn't actually meet too many farmers who were using the system and so on. So all of the outreach work happened much before I joined. But we did get a chance to do one field study about one app that we were trying to sort of look at. And so I met actually just one grape farmer in Nashik. And they are really, I mean, they are good with technology and they are pretty well off. But yeah. So I personally really did not interact with too many of them.
Okay, all right. One more question here. So from Shimran Chopra. So she says, thank you for sharing your work. Manjiri, I wanted to ask, what would be the long-term sustainability and adoption by the pre-urban and remote communities who you approach with the intervention?
Right. So again, similar. So I just wanted to check if you had a particular project in mind, or was it a more general question?
I wanted to ask about the ones that you've not the typing ones, but the other ones that you've done. Like, how do you think that it became more than an intervention or a research within the community? That was my question. Like, how do you think that it got adopted or was sustainable enough to carry on from just the research?
Yeah. Actually, good point. So Aqua was deployed. It was functional for a very long time, and by the time I joined in 2006, it was actually already spinning off into a startup. So I think 2007 onwards, actually there was a startup that picked up part of the work, and it sustained for I think several years before it was bought out by somebody else. I don't remember their name, but it did. It was deployed in the field. It was actively used by real users, and real content was generated for sure. Then, as far as the keyboard, obviously is on Play Store, so it has active users, and it's sort of gone from the lab to the field. And Android actually made it possible because we didn't really have to invest anything. We created an app. As technology's easiest thing to do is make an app and put it out there, and so that we could do. And there has been a lot of positive feedback that came from people and so on. And we did a couple of iterations and so on. So that happened. The mMitra project that I spoke about. So again, the IVR service, so it was a very short collaboration. So the IVR service was already deployed with, so it was a pilot program. It was, so they actually had live users enrolled in the program. They had already been running it for 1.5 years. So people had been using it when they were expecting to. Now they had, their infants were 18 months old and so on when we joined in. And so our association with them was very brief. So they wanted us to sort of evaluate as a outside design team, evaluate how their program was doing in specific, whether IVR is effective or not, can an app help, and so on. So our job in that sense was limited. And we went back with the feedback that we had on what they could change or in their existing system in terms of content, and if they wanted to make an app or multimedia content, like they had animations and so on. So we also gave them some pointers about what that should have and what it should look like and so on from my experiences. So in that respect, we don't know whether it was picked up or not, because it's a private body. So unless it actually comes out, whenever it comes out, we'll know about it. Yeah, so the last one, that Let's, is still sort of picking up. So it's still in lab, but hopefully it'll go into deployment at some point. So they're still looking for funding opportunities and so on. But so hence I wanted to title it that way, because luckily I got to be part of these projects that actually ended up going from the lab to being deployed. So that was interesting.
Okay.
Thank you for that.
Cool.
All right. All right. I think there's no more questions. And thank you.